We'll see another problem in this video lecture on suddenly applied load as well as impact load, right? Let's get started. And the question is given: a steel rod 40 mm dia is 2.5 meters long. Okay, find the maximum instantaneous stress, that is instantly generated stress induced when a pull of 80 kilonewton is applied. First find out gradually applied load, gradually. Second, find suddenly applied load. Next, find out the maximum instantaneous elongation. So in the question it is given that a rod of 40 mm in diameter and 2.5 mm in long length, right? Find out the maximum instantaneous stress induced when a pull kind of load, that means axial tensile load of 80 kilonewton is applied. So first we'll find out the gradual, then sudden, then maximum instantaneous elongation. Yeah, let us write the given data. First, T equals to 40 mm, L equals to 2.5 mm, that is length is 2.5 mm, diameter is 40 mm, 2.5 meters converting to mm, it will be 2500 mm, right? Next we'll find out, directly we'll jump into the solution. First one is, for gradual applied load we already know the formula, that is load upon area. For gradual applied load, the maximum stress will be same as normal stress, that is given by sigma equals to P upon area. So now from this we can write 80 kilonewton, that is kilonewton into convert into newtons 10 to the power of 3. Area is pi by 4 d square because it is a bar circular section, right? And diameter is 40 mm, right? So pi by 4 d squared, so d is 40 square. So put the values here. (80) into to the power of 3 divided by pi by 4 d square, 40 square. So we got 63.66 Newton per mm square, right? So what is the value of gradually applied load on the bar? That is 63.66 Newton per mm square. So let us say this is the equation 1, because we need to find out the instantaneous elongation. instant elongation, right? So for finding out the instant elongation, we have to know the sigma value, that is stress value, right? So instantaneous elongation is given by delta L equals to sigma multiplied by length upon Young's modulus. Put the values here. We know sigma, that is 63.66 into what is the length? Length is 2.5 meters, that is 2500 mm upon E is given as 105 into 10 to the power of 3, right? So if E is given, take the E. Okay, next put the values, we will get the answer, that is 1.516 mm. So this is instantaneous elongation when gradually applied load. So after sudden applied load, this elongation going to change instantaneously, right? So let us say this as equation number 2, right? So now we'll find out the sudden applied load, again we'll find out the instant elongation. So don't get confused. So we are doing for every step. So let us say for sudden applied load, the stress formula will be given by sigma equals to how much? 2p upon area. So this is for suddenly applied load. So don't forget this, sigma equals to 2p upon area. So if you put the values, 2 multiplied by 80 into 10 to the power of 3 upon pi by 4 d square, that is 40 square. So the stress value for suddenly applied load will be 127.32 Newton per mm square. Okay. So let us say this is equation number 3. So now we'll find out the instant elongation again. So for instant elongation, instantaneous elongation is given by I will write here delta L equals to sigma multiplied by length upon Young's modulus. So that will be 127. So this is the stress obtained for suddenly applied load. Don't forget, this is caused by the sudden applied load. So 127 into, so let us write in 0.32 into 2500 upon 105 into 10 to the power of 3. So this will be your instant elongation after suddenly applied load. So that is delta L equals to 3.03 mm. So that is the elongation after suddenly applied load, right? So now you got this. So I will write here stress in suddenly applied load will be double the stress, yeah, you have to note this important point, that is the stress in suddenly applied load will be double the stress in gradually applied load. So you have to remember, so gradually applied load, let us say the value is 63. So for the suddenly applied load it is doubled, it is multiplied, so then in applied gradually applied loading, right? And as well as the stress is doubled, along with that the deflection, or you can say instantaneous elongation, is also will also double, right? So this is a point you have to remember, double than the suddenly applied load, sorry, double than gradually applied load. So deflection also going to be double, and as well as stress is going to be double. It is a practical example. Previously in gradually applied load we got the value that is half of this, then after the suddenly applied load the value is increases, because we know the formula, that is sigma equals to 2p. Okay, the load will increase, and that means the strain energy, the force also doubled. So this is how you can find out the suddenly applied load. Okay, now we'll see another problem on impact load. So a material or a load is falling from certain height, suddenly it is going to impact the material or a body. So let's see how to determine the instantaneous stresses and elongation, right? Yep. Here is the question: determine the instantaneous stress and deflection of a rod of 1 meter length of 6 mm diameter. So that is diameter is given, that is 6 mm, and the length of the rod is 1 meter. So now the interesting part, if a mass of 50 kg, if the mass of 50 kg fall, so remember this word fall, through a height of 10 centimeter, and what happened, and strikes the bottom of the rod. So assume E will be 120 gigapascal, right? So we can repeat the question now. So determine the instantaneous stress and deflection of a rod. Let us say this is a rod and this is 1 meter in length and 6 mm in the dia, right? okay, 6 mm in dia. So now we'll find out, and it is saying if a mass of 50 kg, so that means some 50 kg bag or 50 kg weight is going to strike on this rod, falling through the height of 10 centimeters and striking the bottom of the rod. Assume E value is given. Let us try to draw here. Usually you can see this kind of setup in gym, where if you lift a load, let us say this is a 50 kg load, it will constantly, if you lift it, it will go up, and if you release suddenly, it will come and strike this bottom, right? So this will be the collar, and this is a rod, and this is a load. Right, and the length is given of the rod is 1 meter, and it is striking from a height that is 10 centimeter. So he is asking to find out the stress, that is impact stress, and the next one is delta L, that is elongation or deflection, and you can call it as change in shape or dimension, right? So let us write here D equals to 6 mm, that is dia is given, length is given 1 meter, that is equals to 1000 mm, and the mass is also given. What is the mass? 50 kgs, right? And height is given, that is 10 centimeters. If you convert into meters, mm, it will be 100 mm, right? So what kind of loading? Let us see. So type of loading, let us say solution, type is impact load, right? So we know weight is nothing but the mass into acceleration, right, due to gravity. Weight, we know that mass into acceleration due to gravity, we studied in our school time. So that is W equals to m into G. M is 50, and we know the acceleration of due to gravity, we can take 9.81, right? So now I got the value of weight, that is 490.5 Newton. So this is the force with which it is going to strike the bottom of the bar. Clear, right? Next, for impact, we know the formula, one of the biggest formula till date. Stress is given by sigma equals to P upon A plus under root P upon A whole square plus 2E pH upon AL. So E is Young's modulus, P is load, H is the height, L is the length, and A is the cross sectional area of the rod. So all the values we have, just put the values in the formula, right? So what is the cross section area? So this is a circular section, so the cross section area will be pi by 4 d square. D is 6 mm, that is 6 square, so we got 28.27, right, 27 mm square. Now put the values in the equation. So you got all the values, put the values in the formula. That is, load we got is 490.5 upon cross sectional area 280.27 plus under root 490.5 upon 28.24. Is it 28.24? Yes, this is 28.24. Yeah, whole square plus 2 into 210 into 10 to the power of 3 into 490.5 into 100, right? That is the height, 100 is the height, upon 28.24 into 1000, that is the length. Put the value, all the stuff in the calci, will get 87.1.7 Newton per mm square, right? If any numerical mistake, please ignore that. You know, if you want to check, please check and comment below. So this is how you can find the impact stress, right? So now we'll try to see the instant deflection or instant elongation, right? So instant elongation, instantaneous deflection, that is delta L equals to sigma multiplied by length upon Young's modulus. From this we'll get 871.17. So we got the sigma here upon, so multiplied by length is 10 to the power of 3 or 1000 upon Young's modulus, that is 210 multiplied by 10 to the power of 3, right? So we got the elongation, deflection is 4.15 mm delta L, right? So now you got the deflection, right? We got the deflection, we got the stress, we got the impact stress. So this is the formula, and this is how you can calculate the instantaneous deflection, that is delta L equals to sigma multiplied by length upon Young's modulus or modulus of elasticity. So that's it for today's class. Hope you enjoy the class. Be safe. Take care. Bye bye. We'll see you in the next class.